Alright, today we're going to be learning how to do luminescence measurements on the plate reader. This is the EnVision multi-mode plate reader, and because we're doing luminescence, we're going to use a white plate that helps bounce back all of the signal towards the detector. If you have a clear bottom, then you'll be able to also do microscopy on the same plate, but if you only want to do plate reading, then the solid white plate is your best bet. We'll start by opening EnVision Manager software. If you're on the old plate reader, then it's called Wallach EnVision Manager, but on this one it's just called EnVision Manager. And so we're going to go here into the navigation tree and click on Protocols. You can navigate this tree using the little plus, folder opening little things. And then we're going to open, in this case, in my folder, I think this is the one that I was messing with. Okay. So we have a luminescence protocol, and if you make a copy of somebody else's protocol, then you can just relabel it with your lab's name and save it in your lab's folder. That way, if you're making edits to it, you're not going to affect that lab stuff and they wouldn't realize. And so you set here in this first window the plate type. We were going to use a 3 to 4 well plate. There's all kinds of options, but we just picked the general, and that works for most plates. Rotated plate is if for some reason you're going to be loading your plate upside down. The gripper height has to do with the holder that takes the plate in to make sure it grabs in the right spot. The measurement height is usually defined in the label, and that's fine. You can overwrite that here if you need to. So the measurement mode. These are the options for measurement mode. If you do by rows, then it's going to go measure, 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 and then go back to the beginning, and then measure, 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 and then go back. If you do by columns, it's going to go measure, measure, measure down the column, and then go back to the start, and then measure, 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 and that's how it's going to work through the plate. If you do bidirectional, with the rows, it'll be measure, 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 and then it just goes down one, measure, 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 and then it goes down another one, like a snake. And so that's the fastest way. Also fast, but a little bit less fast is if you do it by column, and if you do measure, 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 and then it would come back and measure, measure, measure on the way back up. This will also be a snake, but it'll have more switchbacks, so it won't be quite as fast. So I always just say by rows, bidirectional. That's my favorite. That's the fastest. And yeah, this is where you would set unlimited plates if you wanted to just read a whole stack of plates, but normally we just do one plate. For most labs, you usually just have one. And then we're gonna say here in the output settings window, in addition to the file that it already automatically gets saved into the device, like its database will automatically save all the data that you ever collect. In addition to that, you can have it export a CSV file that you can then easily put on your thumb drive and take home and analyze in Excel or some other spreadsheet software. So if you want to do that, then you click yes on this file output button, and you can define the place where you want it saved and the automated file name, how it's going to be structured, and put that it's .csv at the end. And you get to choose how you want that data table to look. If you choose plate format, then the rows and the columns of the plate are the rows and the columns in your spreadsheet. If you choose list format, then there's going to be one column that's just well name. It'll go A1, A2, A3, B1, B2, B3, a whole list. And then the next column will be the measurement that was taken. That's really useful if you're doing like calculations, because then you can just add a column and it'll be like average or standard deviation or whatever. You can just add your columns instead of, if it's on a plate format, then it's a bit hard to know where to put that. And there's other options for what all you want to include in that data table. I usually just put everything at the end. The next thing here has to do with repeats, and these questions have to do with how many times you want each plate read in a sequence, and the other option is for how many times you want the whole stack of plates read. And so we can set that up for your experiment if you have a time course. And then there's a wells selection tab where you set which wells you want to be read. If you say here undefined measured, then that will, and you just click on the whole plate, then that will measure everything. Or, you know, if you just have your samples in one column, or maybe you just have those wells, then you only have to measure those wells. You do have the option of setting where the blank is, like if you had some blank wells, you can tell it that you have some standards if you have a standard curve. You can even tell it where your samples are, they're the unknowns. And if you just select like that, it'll say unknown 1, unknown 2, unknown 3. But there's other options here, like for example, if you were doing your experiment in triplicate, then you could say, if you selected it now, it goes 1, 1, 1, 2, 2, 2, 3, 3, 3 for the triplicate. So there, it looks very complicated. This is really just to label what's what in your plate. And that's only important for if you want the computer to do calculations and graphs for you, then it will need to know what's what. But if you're doing your own calculations and graphs, then you can just say undefined and measured and pick whichever wells you want. I'm just going to pick one row for this demo. This protocol has a shaking step. When you do shaking of your plate while the plate's inside the device, you can set what kind of shaking you want. Linear shaking will shake your plate back and forth. Orbital shaking, it'll go in a circle, and double orbital, it'll go like an infinity symbol, and that kind of depends on what sort of thing you're trying to mix. And you can set how long you're going to shake for, how fast you're going to shake, and like how big that diameter is going to be. And then you can add more steps to your protocol using this little down arrow. Like if you wanted to add a delay, for example, or you wanted to add a step where the temperature is going to come on and heat it to a certain temperature, those are all options. Our next step is a measurement, and it's going to refer to this measurement file that's for luminescence. So all of the protocols referring to this measurement will all use these same settings that you can see if you click on this label button. It looks like a little molecule. So if you click there, it tells you how that measurement is going to be measured by all the protocols referring to it. And importantly for luminescence, it's going to say what aperture you have. For this protocol, we have a 384 well plate. We're going to use a 384 well aperture. That aperture is the one that's the default in the device. So if you ever use anything else, just put that one back when you're done, because most people are going to use 384 well plates, and so we're ready for that. If you have a 96 well plate, you can still use the 384 well aperture, so you don't have to change it out, but you'll get a better signal if you change it for the 96 well aperture, and in a minute you'll see why. You should make sure there's some distance between it and the detector, or between your plate and the detector, so that they don't crash into each other. The measurement time is really important. If you want your measurements to happen really quickly, you don't want to stand around too long, then you can make this short like this. But you could even do a second or 10 seconds if your signal's really low and you need to collect as much photons as you want, or as you can. And then the glow correction factor, that's for if you want it to calculate based on the adjacent wells. So like if you have a really dim well next to a really bright well, then if there's a slight signal in the dim well, it might be because the light's coming in from the adjacent well, since all of them are glowing at the same time. And so it's really smart. It can figure out, oh, there's a really bright well here, so let me subtract a little bit of that signal from all of the wells next to it. So you can set that here, but most people prefer to set that later in the calculations step. So if we go back, see, this is all the protocols that are currently using the same label. So if I had changed the label, then all of these would get affected. That's why it's important to have a copy for your own lab. Not in this case, like the Loki lab and the Rubin lab are sharing it. So if somebody changed this to 10 seconds and somebody from the other lab came in and was just expecting it to be the same as always, they would get a big surprise that it wasn't 0.1 seconds, suddenly it was 10 seconds. So you should make your own copy. And then So the last step here is the calculations. In this case, we're doing luminescence, so it's good to have a crosstalk calculation, and that you can set, by clicking here. There's all the different calculations that can be performed. A lot of these are not, you can't click on it right now, like the blank one. That's because we haven't defined a blank. If you had defined the blank in that plate map page, then those are the calculations that would be possible. And also some graphs and standard curves and things like that. But what you can do for this is just calculating the crosstalk. And so, yeah, we're ready to run the plate. Well, let me delete the shake step because we don't want to wait around for that. And we can say start and save the changes. If you say no, it will actually run the previous protocol. It'll forget all the changes you just made for this run. It's not like it's gonna just not save it but still run it. So yeah, that's important to know. Oh, I didn't put the plate in. Okay, so it's first just initializing, so I had a very quick second to put the plate in. Normally put it in beforehand. Or maybe it didn't like that. Oh, it just never saw my plate, so we're just go with start again. Okay, so you just hit start, and the plate is in here, and you can see the little gripper will come up and grab it at that gripper height that you had set. I'll take it inside for the measurements. And you should see the measurements populate on the screen. In this case, it was the 0.1 second measurements, so it's pretty quick. And it was a blank sample. There's nothing in the well, so that's why it's really low. Hopefully you would get measurements higher than, this is like 50 intensity units. And the plate just comes out over here. So what if you needed to change the aperture? What if you're doing a 96 well plate, you got a really low signal, now you want to try changing the aperture to increase your signal? For that, you need to remove the stackers. And lift up the casing, and inside here is where the apertures are. It's actually back here. There we go, that thing. Sweet. We'll keep that one. So I'm just gonna reach in and unscrew it. So this is the aperture. So all I was doing is unscrewing it like this and then pulling it out. And you'll be able to feel this little stick. It's the only thing around here that has any kind of stick sticking out. So now there's just a little hole where it usually goes. Okay, so this is the aperture. The other apertures are kept in a case down here that says on it Luminescence apertures. And we've got 3 sizes. There's a few copies of each one, but there's 3 sizes. This one is a 96 well aperture. This one is that 384 well aperture that we've just been using. And then for the 1536 well plates, there's the aperture. So let's set them out so you can see the difference in size. These sizes are matching the well size. So that's like, that little square is how big the 1536 well is, and then the 384 well, and the 96 well. So that's why you get a better signal with the bigger hole. But if you had a 384 well plate with the 96 well aperture, then you're going to be allowing light through that came from the adjacent wells, because it won't be blocking those with the aperture. That's what this is for. If you're doing fluorescence, you don't need an aperture, and it won't use it, so it doesn't matter if it's in or not in. This is only important for luminescence. So let's see, the 96 well goes here. 1536 one goes here. put it back in. This is going to be really hard to film. So on the edge of this thing, you can see there's like these, I don't know how to call this, like a sloping thing there. That's what you're going to be feeding into a position, and then that's what it will rest on. It's that little lip there that's going to hold it in place. So as you're feeling this to put inside, you'll feel that there's a ledge that it just slides into like that, like a little slot. And then once it's in, then you'll screw it into place. If you don't think it's on, it's not on. It's a very, very precise little ledge that it fits onto. If it's not in right, it won't let you screw it in. So that's another way to know if it's in or not. Yes. So when it like pushes in and it lets you screw it on, then you know it's in. Okay, and you just close the lid, put the stackers back. And once all of the stackers are back on, it will automatically sense that you've changed the aperture. If you have the correct aperture loaded for your protocol, then that protocol is going to have a little star asterisk next to it. But if you've loaded the wrong aperture that doesn't match what your protocol specifies, then the star won't be there. So let's, for example, if you try running, I'm just going to open one of the protocols that does not have a star, like this 96 well one. We put the 384 well one in. So if I try and run this protocol, it gives this error message. Cannot start the assay. Click details for more information. So click the details here. This is one of the few devices that actually gives you a very useful message, and so it tells exactly what went wrong with that protocol, so you know what to fix. But our protocol that has a 384 well aperture, it has a little star next to it. It also is green over here, so you know it's ready to go. Did we run the plate yet? I don't think. Yeah, we did run the plate. All right, I think that's everything you need to know about luminescence reading on the plate reader.